Stanford University.
So let me just start out by this panel session that we have until, I believe, like 12:30, right? By asking the other three of you the same question, I guess, that just came up. And I mean, do you have any particular data warehouse design methodologies that you use?
Data warehouse design methodology, I'm not exactly sure. Is that about like the table schema and things like that? Okay, so very briefly, on Facebook, basically the Hadoop warehouse, we have basically the same set of tables. It's a dimension table, fact table, and derived tables like summaries. So the majority of data has been the fact table. The dimension table is relatively small. Also, for the dimension tables, we are like experimenting a new way of getting the data from fact table. So the basic idea is to get all the changes to dimensions as a log, and then feed that into a fact table, and then eventually join with the old version of the dimension table to get the new one. Apart from that, I don't have any other details. I guess I will let other speakers.
I think for eBay, it depends at what time you ask the question. I think you usually see an evolution going through, and you know the steps were bolder in the beginning, where we had a listing table for each country, right? Today we don't have that anymore. So we certainly want to move into towards the third normal form. I think we are fairly close to that, but it's definitely not enforced. We have aggregation tables. Slightly different for the singularity system. The singularity system, as you've seen it, is by definition already denormalized. It already has a combination of several other tables in the same table as part of the semi-structured information. Hadoop is wide open, right? Hadoop is getting the data the way the enterprise or the singularity system is spitting it out, or the EDW system is spitting them out. And then on the Hadoop side, they will massage the data in place that is appropriate for the type of processing they do. We try to keep track of that, and trying to build tools around that to allow us to capture that information automatically, but it's not fully in place yet.
So I actually work the least on data warehousing things, but from what I've seen, it's sort of an even split between sort of more relational warehousing software or stacks, and Hadoop being used for a large bunch of essentially efficient scans. One of the things I think that comes up, especially in LinkedIn and maybe Facebook as well, is a lot of graph processing, and that tends to sort of throw a wrench into traditional data models. So that's something interesting.
I think I'd just like to add two more things. One is that the nested relational model actually adds some interesting twists to the typical data modeling standards, I guess, currently in place. So if you take, for example, the concept of, I don't know, the Kimball-ish kind of bridge tables, right? Where's that many-to-many relationship? How do you do that? You use a bridge table, and then you kind of assign arbitrary percentage points, so that, you know, this is 0.1, this is 0.3, blah, blah. You can do that in our case, for example, since we have good support for nested relational, you can actually add a repeated field to the dimension table and convert that into a one-to-many relationship. And you can ask questions like, okay, what is the total revenue of country that contains feature X, which would be kind of more difficult to do in purely relation model, in a purely like Kimball-ish kind of model. The second thing is that some of the dynamics in terms of cost economics changes things somewhat. So data is now very cheap, and one-off processing is cheap, but it is very important to get data out fast, and joins are expensive. So this kind of adds up to the fact that there is more and more trend towards denormalizing fact tables, which was obviously Kimball frowns upon very deeply. I believe his face has permanent creases because of that, but maybe other reason, I don't know. But we tend to denormalize a lot of our fact tables and bring in especially the non-SCD2 kind of dimension attributes. If you discount SCD2, then it makes much more sense to denormalize a lot of the data into the fact table, because scan is way, way faster than joins.
Okay, along a similar kind of lines, there was a question about consistency verification, and there's also another question sort of about do you actually back up your data? Because I mean, you all have methods for dealing with hardware failures, but do you have methods for dealing with software failures in the sense of applications actually corrupting data along the way, your ETL applications or other things? So do you want to speak to those?
Okay, from our perspective, I guess since we are kind of a downstream systems, the logs are pretty much sacrosanct. So we never change the logs. So if something goes wrong downstream, like because of an application bug, our simple solution is to just reprocess the data. And having a like 10,000 node cluster makes it an easy decision to make.
This was kind of a very relevant question because as we were working on Espresso, this was one of the main questions that came up because we were sort of looking at replacing Oracle for some of the use cases. And you know, Oracle comes with not just the primary store, but also a set of tools around backup, restore, and DBAs can do this all day, all night without, and it's a proven suite. So one of the conscious decisions we made as part of Espresso was to build out sort of the backup and restore capabilities from day one. And using MySQL helped us a lot that way because MySQL has a good community, and getting online backups of DB tables and having the cluster manager essentially allows us to do that. So basically, it's a scheduled job which goes in, and every configurable interval goes in, takes online backups of each partition, and then moves them off. So that's sort of.
So at Facebook, we also, of course, do reprocessing of the data if some of the summaries, the software has a problem. So in addition to that, another important thing is on the log data streams that we are getting. So basically, on each step of the data transfer, we have some beacon messages or like trace messages, which allows us to track how many messages are lost, how many messages are duplicated. So we do a small sample to make sure that our system performs well. So there are cases that we lost a little bit of data, but as soon as we fix the data, as long as we fix the data fast enough, usually it's still okay for our customers.
Okay, and might take me the longest to actually respond to that one. On the enterprise data warehouse, this is the most mature environment, and this is the stuff that has a lot of value to eBay. We have backups. We do a full system backup once a week. That's going on just a disk in a parallel way. So we are backing up about 10 terabytes an hour. It's an inconsistent backup, right? It takes 2, 3, 4 days to run during regular operations. But we figured, okay, we can restore that and actually can identify the rows that has been inserted into those tables after the date we are shooting for. And so we can reset. In addition, we have a second system today. In the future, the second system will go away. We do have all the EDW data on the Singularity box because we want to join that anyway. So there is another copy of the data. For the user behavior information, the data is being, these are log data that is not changing, all right? It's just being added to it over time. So we have the same data on Hadoop, so we could actually get back from Hadoop. One of the things we haven't really addressed towards the first part of your question is really consistency. And that, I think, where there is a devil in the details. We saw problems with shipping large amounts of data because you have to balance, right, efficiency versus accuracy, especially once we leave the realm of a relational database that takes care of it to a certain degree. But especially on the Hadoop side, since it's an append-only kind of environment, it's posing some challenges there.
Okay. Another question having to do with sort of performance is that compression was actually mentioned as being something that you find very important for saving space and saving time in terms of I/O, but you're paying it back by spending CPU. So what's the trade-off look like there, and are any of the others of you who didn't mention compression at all, are you using it all?
I think it's widely used in large systems, right? It's being used on Hadoop as well. So we worked with Teradata to introduce that feature to actually save I/O and pay with CPU, because I/O is expensive, right? As I said, the Singularity system has less bandwidth behind each node, so and the CPU is actually evolving in our favor, right? It's growing way faster than I/O. So we are willing to put more CPU in those nodes and actually pay for that. And the other thing is too, mainly you pay at the write side, right? You're paying less at the read side.
So at Facebook, we also use a lot of compression technologies around different places. So we use Quick LZ, LZO, gzip, as well as LZMA at different places because of the performance space trade-off. So in the log streams, we use Quick LZ, which is almost as fast as the network, or even faster than the network. So eventually, when we archive the data, we use LZMA, which has the highest compression ratio that we have seen right now. So apart from that, I think there's a new open source Google compression library called Snappy. We plan to use that as well.
Yeah, very similar to what Zheng said. We use compression in our transport layer a fair bit. Kafka, for example, has end-to-end compression so that data gets compressed at the source, stays compressed when it's on disk, and actually gets decompressed only at the consumer side, because that's where you kind of have more plentiful CPU in general. For Espresso and even for Voldemort, I think we've played around with compression a fair bit. It affects your caching as well, because you can use more of your memory and store more rows. So yeah, it's definitely something we use.
From Google side, I think a couple of interesting things on compression. One is that one of the things that we do with MapReduce is we actually shard and sort in the reducer on different values. That is pretty interesting because let us say you are sharding on column A, which shards very evenly but doesn't compress as well. But if you then sort it on column B, which has little variation, then you can get very good compression, especially if you're using column I/O. So one of the nice things about column I/O is that the individual columns are compressed separately. So if you can get sort on a highly compressible column, especially that's a highly used column as well, something like date, for example, that gives you very good compression and query performance without too much CPU cost. In terms of algorithms, we have our own. So we essentially use 3. Where the CPU cost is important, we have our own solution, like you mentioned. We also use standard, LZW compression on column I/O. We are currently experimenting with some interesting new types of compression on columnar data, which are based on a deeper knowledge of the data. And for our records, we just use the standard records compression.
Okay. Also, in the performance arena, how do you see the trade-off evolving between moving compute to data and moving data to compute as networks get faster and faster and CPUs get faster and faster, but I/O bandwidth is still kind of limited?
Yeah. So I think we do a little bit of both. With Bigtable, we have this concept of writing custom processes that can run very close to the data. We call them like co-processors, and they help in moving the compute close to the data. In general, though, in our current stack, we kind of believe in segregating the computation from the data to a large extent, except when we are doing filtering. So a lot of the filtering in terms of which rows to access and which column to access can be pushed down. But after that, any of the more complex logic actually happens in the aggregation layer. So we believe that you have to choose in terms of what operations you want to push down to the data and what operation you want to have dedicated nodes for.
Yeah, very similar. We sort of went through that trade-off exercise while designing sort of the API for Espresso and trying to figure out what are the things that will support on a single node and what we'll just ask the application to do. So very similar. We chose just simple query processing on the single node and left more complex stuff for.
But do you see that changing as we go into the future? I mean, do the trends point in a particular direction for you?
Well, I don't think so. I mean, what we're finding is you're getting much better. You're getting much more options for storage and RAM-based locality as well. So networks, network architectures, even though the networks tend to get faster, when you finally lay them out on a data center, and if you end up going with sort of traditional networking gear, you end up getting into a lot of bottlenecks out of the rack and then across the racks and stuff like that. So I think there's still some space for innovation there. And once we see true mesh connectivity from one node to any other node in the data center, then you can start doing these things. But otherwise, it gets pretty tricky.
Yeah, so from my side, I feel actually there is a trend of for some of the computation to move to, for some of the data to move to computation because of one reason is the network bandwidth increase, and another reason is because more and more of the data processing becomes stream processing nowadays. So if we think about all the files that got stored on HDFS, Hadoop file system, then of course the most efficient way is to move the computation to data because data is already stored on disk there. And usually the amount of data that needs to be processed is huge. But when we think about the stream processing, which is more and more popular nowadays, for stream processing, the amount of data that got processed at each particular moment is actually not that large compared with like back processing 1 year of historical data. So as a result, network is actually can easily like handle the workload, and our current performance bottleneck is actually our memory. But for the log delivery systems, we do plan to do more and more like data transportation, and we do plan to use the faster network gear like 10 gig NIC in the near future.
I think from our side, we are embracing both, right? So I think our primary goal is to do the right thing with the right tool and connect those tools together. That's our vision. And you know, the forces will change over time, right? So with SSDs coming out, so end of the month we are deploying the first SSD or partially SSD-based Teradata system as an enterprise data warehouse, which obviously will help a lot on the I/O side on that platform. But on the other side, we already know, hey, we need the same EDW data on Hadoop. We need the same EDW data on Singularity because there we can do other processing. So we know we need to, there is a co-opetition, right? And we need to work on in both dimensions.
Yeah, this is something I realized once talked about stream processing. So I think there are two different paradigms really. One is where you've got static data and you have a real-time request or a batch computation that's going on and you want to figure out, do I pull the data out to me and then work on it or move the computation closer to the data? In case of streams, where in a lot of cases they're not even materialized, they're actually flowing through the network, it definitely makes sense to have the stream come to you than for you to go to the stream, because there's probably not a single home for the stream anyways.
Okay, changing gears a little bit from the performance side, there was a question about, I think at least 3 of you have some kind of a product that's out as open source. And what has your experience with that been? Or do you get any unexpected benefits from open sourcing things? And are there any plans for eBay to open source any of its technologies, the ones you haven't bought?
Okay, at least that gives me a reason to talk. No, we are very interested in open source. We actually started that. It was a little bumpy road to get all the approvals for that stuff. But we are working on open source in 2 areas. One is obviously Hadoop. We did hire some committers on the Hadoop platform. We have a very high interest to actually make that platform work and make that platform more efficient. The second one is, and there was only a hint on my slides about the analytics community and the social analytics, the program where we try to actually combine everything, those platforms and all the tools underneath one umbrella and allow everybody to be used as a Facebook and as a LinkedIn and as whatever for analytics within eBay. So that is based on Joomla, and we have several Joomla committers on staff to actually work in that direction.
Facebook do have a pretty long history of open sourcing the projects, like Scribe and Hive and Swift all got open source from Facebook. So the most obvious benefit we get, I think, is like the adoption of the technology from the industry and get the recognition so that we can get better hiring results. So if you guys are interested in working on open source, then if you guys can consider. So another benefit of course we also get is contribution from the open source community. I think on that front, actually, we do have some good experience, and we also have some lessons. The lesson is basically on like how do we coordinate the internal changes and external changes. And we work both on the Apache websites, like for Hadoop and Hive-related projects, as well as GitHub for some of the other projects. I think that there are benefits of both. Apache is a better organized and better controlled, and GitHub it's kind of a free form because everybody can just fork Git and do whatever he wants. So I think we are just still learning, trying to see what is the best way, but I'm pretty sure open source is a very big direction that Facebook is going to continue to support.
I think similar to Facebook, LinkedIn has had a pretty long history of open source. Voldemort, as I said, was one of the first open source distributed data stores out there. And we've seen all the products almost that I talked about are open source. So it tends to lead to a very interesting question around roadmap and figuring out where you take a particular product and being able to make those decisions not just within the company, but actually with the community. And that's something that all of us are sort of getting better at in figuring out how we message to the rest of the community about where we're going to take the product and help them help us in contributing in the right way. Because let's say we're working on compression in-house and we don't tell the community about it and someone submits a compression patch, then it's kind of redundant work. In terms of benefits, it's a lot because the first thing that you get is just because of the fact that you're open sourcing it, you kind of commit yourself to writing better code because you know that the moment you're going to open source it, people are going to look at it. The second thing you get for free is QA. I remember Kafka went open source while I was at LinkedIn, and within a few days, people were using it and submitting bug reports, and it was awesome. And we hadn't even got a full-time QA assigned to that project at that time because it was still kind of in prototype, and we were just trying it out stage. So there are a lot of these benefits, and there are also these. What I'm realizing is that a lot of open source projects are getting cross-company contributions. So you see, I mean, Hadoop is a great example of that, but then I hope there'll be more such projects. I think Zookeeper is another good example, where it's not just one company backing it and a lot of other, single-person companies or, two people startups trying to use it, but more larger companies that are sort of working across these divides. And
well, you're getting into my next question.
Sorry.
Okay, so from a lot of the, I think Google has a fairly big open source department. Chris DiBona is heading that, and we do a lot of open source stuff, as you know, WebM and things like that, Chrome, Android, and so on. So on specifically on this front, a lot of the technologies, underlying technologies that I talked about, obviously are open source. As you know, Sawzall is open source. Protocol buffers themselves are open source. Here, based on one of the, I think I frequently get asked this question that, for example, will Tenzing be open source or Dremel be open source, or So the problem, the main problem there is, while the technology itself is not difficult to open source, it is so closely tied. Google has kind of one code base. So it's so closely tied with various other parts of Google code base, which are like licensed from third parties and developed and or contain our proprietary stuff. And then it becomes very tricky to open source, and the approval process itself takes like months and months and months. So there are some other things in the pipeline that we are planning. Unfortunately, I'm not at liberty to divulge what. I'm sure you will get to know when the time comes. One of the things that we do try to do, though, whenever these problems come up, is we try to do what I'm doing right now. So we come up with papers, with presentations. So, for example, the GFS paper, the Bigtable paper, the MapReduce paper, the Dremel Tenzing. So we do present to the academia and to the broader industry as a whole how we are tackling certain problems. And I think in the past that has led to projects like HDFS, Hadoop, HBase, and so on, which we think is a great thing for the community as a whole.
Okay, as I kind of hinted, one of the great things is that you have these packages that are out and available for other people to use, and yet you're not sharing them amongst yourselves. So some underlying stuff like Hadoop you are, but some like you have Kafka versus what was it? Data Freeway, and so why are there so many different packages? Why do you feel that you have to invent things yourself? And what are the trade-offs about building something in-house versus using somebody else's open source package versus buying a commercial package?
Since I have the mic, I guess a typical example would be, for example, our own MapReduce implementation as opposed to Hadoop. So there are pros and cons. Obviously, with Hadoop, we would get a far larger development and QA community and something that's more generic. But as I said, with our own MapReduce implementation, we get higher efficiency on our particular platform. We get more tight sort of communication with the other parts of the Google stack. For example, our MapReduce implementation has very, very close links with the way our particular GFS implementation works, the way which our, the whole system infrastructure block-like thing works, the way our storage formats like Recordoy and stuff work. And while some of it is open source, a lot of it is not. So having our own layers after, so the lowest levels are almost always open source, like starting with Linux and the protocol buffers and Sawzall and the base languages and Go and things like that. But as you go higher in the layer, it gets more and more difficult. I think probably, I don't know if my colleagues agree with that or not. But as you go higher up the layer, the more the tie-in becomes to your business and other components which are not easily open sourceable. And therefore the need comes, and the more your specific needs come into the picture as opposed to bringing a very generic thing. So the higher up you go up the stack, I think the more difficult it becomes to reuse or open source or whatever you want to call it, or share.
Yeah, so I think what is also happening is a lot of this data infrastructure tends to get developed, or at least go through this design phases and development phase at around the same time. And that leads to a lot of duplication when you finally look at the end result and you say, oh, LinkedIn's got one messaging system, Facebook has another. So that tends to happen a fair bit. We've tried to be conscientious in trying to reuse as many building blocks as possible. Take Lucene, MySQL, Zookeeper, Avro. We didn't try to reinvent anything that wasn't available at that point. But it gets a little tricky because a lot of these systems are moving targets. And you kind of have to make a guess based on the design principles and the architecture principles to see, can it be what I want it to be? Or does it just not have some things at the right pluggability layers? So HBase and Espresso was one of the things that we were constantly discussing when we were going through the design. And we just wanted a different abstraction level, and HBase was never going to have that. So even though HBase may evolve to eventually having secondary indexes or transactions locally, it's going to be very hard for us to do sort of the pluggability that we really needed at the layer at which we needed it. So it kind of becomes a moving target, and you kind of have to predict where it can go or what the limitations are of the architecture and what you want it to be. The other thing I would like to see actually is more of an open influencing community around when these projects are in the design phase, so that we can see less redundancy when we go open source. So work in progress, I think we are all learning.
Yeah, I completely agree. And I think the timing is basically the biggest issue that we are seeing. So the good thing about Hadoop is when it got open source, there were actually not so many alternatives, and it's already relatively mature. So it definitely helps everybody by letting them use Hadoop by themselves instead of inventing a new one. But I think because of timing for those new projects, it's just become more trickier, because sometimes we don't want to have external dependencies on something that is, let's say, still in the design phase, or we don't know when it's going to come out. And I think there might be one way of making the things better is try to decompose those relatively big projects into smaller components, so that those components can get reused better. So for example, like MapReduce is like a very general purpose portion of Hadoop. And MapReduce can run on top of a Hadoop file system as well as a lot of other file systems. So let's say maybe for some of our project like Puma, right now it works on Scribe data streams. Or maybe we should make the input pluggable so that it can work on some other data stream as well. So I think those are the directions that we are looking for. And hopefully with those changes, it makes it easier to share in the future because different components can just like collaborate with each other much easier.
Yeah. All I can say is I would wish that would happen faster, but I think it's, as the other guy said, you know, it's all timing, and you're talking here to some of the companies that are bleeding edge, and they are facing the problems first, right? And not too many have the same problem, right? So we're working with Teradata on a Hadoop bridge, and you know, there's a Hadoop bridge out from Cloudera. They can ship data, but they just can't ship it fast enough for what we try to have to, or what we have to deal with. I think there will be, as in every other industry, a consolidation happening as soon as requirements settle and it hits the market and there's enough demand out there. But we will always face that, right? And the only thing we can do is try to work together and probably build special interest groups and make it reproducible.
Okay. Oh, kind of related to that, I guess there was a question whether Databus is or will be open source.
Yeah, it will be.
Okay.
It'll probably, since it's a core part of Espresso, we'll probably time it together. So we'll probably open source it around sometime next year.
Okay.
One question then. So just like as I like thinking about like these components, like it's true like these two components are connected together. But if let's say Databus is open source earlier, then actually it makes it easier for other companies to use because of timing issue, right? So would there be any possibility of making that happen earlier?
It's mainly, as Vishwapesh was saying, just stuff that is tied into you know, LinkedIn's build framework and stuff like that. And if there's enough interest, we can definitely try to make that go out earlier before Espresso.
Okay. Well, okay, we are pretty much out of time, but one just very last quick question that just came in, so I might as well ask it. I've heard of use cases where Facebook shards HBase. Can you comment or elaborate?
Shards HBase. So yes, I guess that's the other like the biggest HBase application at Facebook. We use that to store the messages, the Facebook messages that people send. So basically, that's kind of a full text search solution. So the major reason for that is because we, so right now, basically HBase cluster at Facebook is most likely about 100 nodes per cluster. Because for the particular application about Facebook messages, we don't see a huge scale of the data distribution. So if we shard them into multiple smaller clusters, it's actually much easier to manage. Like we have like dozens of 100 node cluster instead of a single thousands of node cluster, and it definitely helps a lot in operations. So I think that's basically based on application. Maybe for some applications this does not work, but it happens to be for our application it works pretty well.
Okay, I'd like to thank the panel for leading us off in a fine fashion here.
For more, please visit us at stanford.edu.